Welcome back, physicists. I'm going to be dealing with section 5.5 again, and this is a special little section about tension. Tension is a force that cables, ropes, and chains will transmit. They'll only transmit tension. You can't push a rope. You can't compress a rope. Right? So if you're given anything like a rope, cable, chain, string, anything like that that's flexible, and it's taut and there's a force on it, you know that it has to be in tension. So you automatically know the direction of the force. Okay, so a couple quick notes here. The direction of the tension is always along the cable. And unless you're told differently, we neglect the mass of the cable. So as a consequence, the cable transmits the magnitude of the tension without any change. All right, so for example, in this, by the way, in the PowerPoint, this is around slide 22, gives some more information on this. But for here, we have a boat pulling a barge connected by a cable. Along the cable, there's tension on each side. Right, the rope, the cable is pulling on the boat, just as it's pulling on the barge over here. And the boat is pulling on the cable, and the barge is pulling on the cable. All right, so let's look at an example here. So we have here, let me write the problem here. So there's a 15 kilogram block, which is W1 in diagram. W because when we talk about force balance, we're going to need to use the weight of it. A 15 kilogram block rests on the floor. A rope is tied to the block and run vertically over a massless pulley. So let me get this down, then we'll go over. Well, let's go over some things now. Massless. We're not taking the mass of the pulley into account. Rests. All right, so V equals 0, A equals 0. No velocity, no acceleration. The other end is attached to a 10 kilogram weight. Find the normal force exerted by the 15 kilogram block on the floor. Okay, so here's our situation up here. All right, here we have the pulley. We have our 15 kilogram mass here. We have our 10 kilogram mass here. So there's tension in the rope that's connecting them. Now note that W2 is pulling up. This T and this T are the same because it's in the same cable. The pulley redirects the force. So a way to look at this type of problem is, let's redraw these here. No, let's skip that. Okay, here. Okay, so here's our 15, and here's our 10 kilogram. Okay, so what I'm doing is I'm taking this and I'm turning it on its side. All right, I'm turning that diagram on its side. You'll see why in a second. So if I turn it on its side, I have W1 equals M1G pointing this way. All right, I flipped it 90 degrees. And I've got T going this way. And I've got N going this way. Okay, so that's the free body diagram. I guess I should have put that free body diagram of weight 1. All right, T and N are in the same direction. Now, for weight 2, draw the free body diagram for that. T, okay, this is same magnitude but opposite direction. And opposite that is M2G. Okay, so that's our situation. And all the pulley is doing is redirecting that force. Okay, it's not changing the force. So this simplifies things by taking out the pulley. So now, when we, let's see, we're going to sum the forces and set that equal to the mass times the acceleration. We're told that we're given that A equals 0 because we're told that it's at rest. Right? So we know that the sum of the forces equals 0. So let's sum those forces. So we have minus M1G. So I'm having forces that are to the left on this free body diagram, negative, ones to the right, positive. Okay, plus N plus T minus T plus M2G. All right, and you see right away that the two tensions cancel for this system. So, and we know that this equals 0. So 0 equals N minus M1G plus M2G. I haven't put our values in yet. It's simplifying. So N equals M1 minus M2 times G. And now we can put our numbers in. 15 kilograms minus 10 kilograms times 9.81 meters per second squared. Oops, don't need that. So our normal force is just 49 newtons. Okay. All right, that's it. We'll do another tension problem in class with traffic lights hanging from cables. But I'm going to leave this here for now. All right. There's going to be one more video on section 5, 6, and that'll be our last one for chapter 5. Okay, bye-bye.